Section 5.2 discusses right triangle trigonometry. So what we have here is a right triangle, and a right triangle is simply a triangle that has a right angle in one of its on one of its vertices. So this is a right angle. So if we have a triangle that contains a right angle, we call that triangle a right triangle. So either angle A or angle B we use as the reference point when we're talking about trigonometry. So to begin with, we're going to use angle A as our reference angle, or maybe I shouldn't say reference angle, but the basis, or kind of what we're using to view the other sides of the triangle. So here we have theta. So looking out from angle theta, we can call side A the length opposite of theta. So here is this A is the side opposite angle theta. We would call side B the side adjacent to angle theta. That just means next to. Adjacent just means next to. And then we have side C, we're going to call that the hypotenuse. And in a right triangle, the hypotenuse is always the side that is opposite the right angle. So the hypotenuse is always the side opposite the right angle. So looking at the three sides of the triangle, side A, B, and C, all the lowercase letters, if we base our kind of the relationships off of angle theta, we can come up with 6 relationships, or 6 ratios. So the 6 possible ratios starting at angle theta are, well, we could say, so 6 possible ratios. What we could have are, well, we could say side A over side B. That's one possible ratio with 2 of the sides. We could take the reciprocal of that, B over A. Looking at 2 of the other sides, how about A and C? We could say A over C or C over A. And then with B and C, we could have B over C and C over B. So there are 6 possible ratios we could come up with by selecting 2 of the sides in a right triangle. Now, these 6 possible ratios form the basis for the 6 trigonometric functions, or trig functions. So we'll start over here with A over C. So if we're looking at angle theta, A over C, well, that's the opposite over the hypotenuse. And the definition for the opposite over the hypotenuse is sine of theta. Let me write that out, though. Sine of theta. Often, though, we'll abbreviate this as sin. Don't pronounce that as sin, it's sine. Moving down to B over C down here. Well, B over C, that's adjacent over the hypotenuse, and adjacent over the hypotenuse is defined as cosine of angle theta. Frequently, this will be abbreviated as cos theta. Okay, jumping over to A over B, this is the opposite over the adjacent side of the triangle, so that is defined as tangent of theta. Oftentimes this is tan theta, like this. Okay, cycling back through, hypotenuse over the opposite side, we call that the cosecant of theta. This will be abbreviated as CSC of theta. The hypotenuse over the adjacent, that is abbreviated, or we call that ratio secant of theta. This is abbreviated as SEC of theta. And then lastly, we have adjacent over adjacent over opposite. We call that cotangent of theta, or COT theta, like this. So the ratios in red, we call these ones the primary trig functions, or trig ratios. The ones in blue we call the secondary trig functions or secondary trig ratios. And what you notice is that the blue ratios, cosecant, secant, cotangent, are all the opposite, shouldn't say opposite, they're all the reciprocals of the primary, or the functions in red. So if we know the sine function, if we know the sine ratio, we can very easily get the cosecant ratio just by taking the reciprocal. Now the primary trig functions or trig ratios are the ones we will use most often. So sine theta is opposite over hypotenuse, cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. Now, we need to memorize all of these ratios. So we need to know that sine theta is opposite over hypotenuse, cosine theta is adjacent over hypotenuse, tangent theta is opposite over adjacent. Now, one way that is helpful for many students to remember these three ratios is it's called SOHCAHTOA. All right, and what this means is, well, sine is opposite over hypotenuse. So sine is opposite over hypotenuse. That's where the SO comes from. Ca, C-A-H, comes from cosine adjacent hypotenuse, and then TOA is tangent opposite adjacent. So tangent opposite adjacent. Now, if you can remember the primary trig functions, coming up with the secondary trig functions, well, we just need to know that if we know sine is opposite over hypotenuse, again, we can very easily get cosecant by just taking the reciprocal, and so on for secant and cotangent. So let's do a couple examples of using these trig functions. This question says, find the value of the 6 trig functions for the given triangle. So we have a triangle, we have an angle, theta, and what we want to do is we want to find sine theta, cosine theta, tangent theta, and then each of the reciprocal functions as well. So cosecant theta, secant theta, and cotangent theta. All right, so secant is opposite over hypotenuse. So the opposite side from angle theta is going to be 8. The hypotenuse is 10. So we would reduce that to 4/5. So sine of theta is equal to 4/5. Cosine of theta is adjacent over hypotenuse. So that's going to be 6 over 10, which reduces to 3/5. And then tangent of theta is opposite over adjacent. That's going to be 8 over 6, which reduces to 4/3. Now, to get the secondary ratios, we can simply take the reciprocals of the primary ratio, or we can that's typically the way folks go about this. Typically, for example, with cosecant, students don't typically remember that cosecant is this ratio right here, hypotenuse over opposite. They just remember that cosecant is the reciprocal of whatever the sine ratio was. So we know that cosecant is the reciprocal of this right here, so this is going to be 5 over 4. Secant theta is the reciprocal of cosine, so that'll be 5 over 3. And then cotangent is the reciprocal of tangent, that'll be 3 over 4. All right, and then one more example here. Find the value of the 6 trig functions for the given triangle. Here we have an angle theta. We have 2 sides. We have the opposite side of 3. We have an adjacent side of root 7, but we don't have the hypotenuse. Let's find the value of the hypotenuse. So because this is a right triangle, we can use the Pythagorean Theorem, which says c squared equals a squared plus b squared. So c squared is going to equal 3 squared plus square root of 7 squared. So c squared equals 3 squared is 9. The square root of 7, let me clean that up a little here. When you square the square root, we just get what's under the radical. So this is just 7. So c squared equals 16 gives us c equal to 4. So we're going to say that this is 4 here. So now that we have all 3 sides of the triangle, we can go ahead and find the value of the 6 trig functions. So sine theta, sine is opposite over hypotenuse. Remember, so, ka, toa. I can write that up here. So, ka, toa. All right, so sine is opposite over hypotenuse. So the opposite from this angle theta is going to be 3. The hypotenuse is 4. Cosine of theta is adjacent over the hypotenuse. And then tangent theta is opposite over adjacent. So that's going to be 3 over square root 7. Now, we need to be careful here because we do not want to leave a radical in the denominator, so we must rationalize the denominator. We do that by multiplying the top and bottom by square root 7. We end up with 3 square root 7 over square root 49, which is 7. So tangent of theta would be 3 root 7 over 7. Okay, moving on to the secondary ratios. So cosecant theta is the reciprocal of sine, so that's going to be 4/3. Secant theta is the reciprocal of cosine, so that will be 4 over square root 7. Again, we must rationalize. We get 4 square root 7 over 7. And then cotangent theta is the reciprocal of tangent. I'm going to take the reciprocal of this right here. So that's square root 7 over 3. If we were to take the reciprocal of this one, we would need to rationalize because you'd end up with a square root 7 in the denominator. So use this one here to find cotangent. And that's it.